So the reason why we are here today is that we will talk about the DevOps for hardware-dependent software as part of the Work Package 3.5 for the Internet of DevOps project. The agenda for today is like this. I'll just talk about what is DevOps and then give you some introduction for GitLab and the architecture of today's demo and the demo itself. So DevOps is basically a set of practices that automates the process between software development and IT teams in order that they can build, test, and release software faster and more reliably. DevOps is a combination of agile and continuous integration, continuous deployments, and automation. And it's all about process, technology, and people, basically. And it is used to remove the silos, so the communication barriers between teams, and improve time to market by the CI and CD, and increase the deployment frequency. With the smaller code change, you can test and also shorten lead time between fixes and faster time to market. And today I will show you the interface of GitLab and also the devices that is connected to the GitLab using GitLab Runner. GitLab is a Git-based code hosting and collaboration platform. It's similar to GitHub and Bitbucket. It's open source and freemium, and it's hosted or on-premise. I will show you the hosted version, so GitLab.com basically. It's actively maintained by the community and also supported by companies as well. So here on the top, you can see some CI/CD pipeline that is offered by GitLab. And today's architecture is like this. I'll be using GitLab in order to push my source code, and then it will be sent to a GitLab runner. I have installed the runner on a Raspberry Pi system, which is basically a Linux system. That system will be triggered by GitLab. Then it will push the source into a hardware, open source hardware, Arduino Uno, and I have an RGB LED, 8 LEDs connected to the Arduino. I will change the colors of the LEDs, and then we will see how it is triggered automatically and how it's programmed to the real board. And the demo. Okay. So can you see my screen still?
Yes.
Okay. So this is the GitLab runner. So it's this is the Raspberry Pi system. It's connected to my power bank, and there's nothing in between. This is connected to the internet through wireless, and I do have the Arduino Uno connected to my USB of the Raspberry Pi system. And this is the RGB light, which is currently blinking in blue and red. So the source code for this Arduino is in gitlab.com. So it's in my repository. It's here. And how I connected my GitLab runner into the cloud is using this settings. So I have installed the GitLab runner on my Arduino and registered it to here so that I can see it's online and it's connected. And it has these settings for the tags. So if I release the code using pi tag, then this will be triggered. And these are the repositories of the current application. I have my Arduino libraries here, and I have the CI/CD settings. If I click here, so here I have two stages. I'll talk about the stages after I make change to the code. So I have build source stage in which I will the Arduino code, and then the deploy to Arduino stage actually copies that built image to the Arduino Uno system. And as you can see, my tag is pi. So if I use this tag, then the GitLab runner that has that tag will trigger. So it's going to be this one. So for different environments, you can have different runners. So for example, you can have pre-prod environment that will be used to trigger the pre-prod code. And then for production, you can have a different GitLab runner or different system. So here, let's make a small code change, and then we will see how it's triggered and how it's programmed to the Arduino Uno. I can directly edit my source from here. So basically, this is Arduino programming. This is red, this is green, this is blue. So I have blue and red. This is blue and this is red. So let's make this green. I'll just make 255 for green. So I'm expecting the RGB LED to be green and red after this. So once I commit my changes, this will be triggered through CI/CD. Okay. Okay, now this is a pending process. Since it's on cloud, I'm expecting to have this triggered within a couple of minutes. If this was on premise, it would take a lot less time for the trigger. This depends on the activities on gitlab.com. So as you can see, it's blue now. So once we click it, you can see that it's currently using the commands to build the Arduino code. I have installed a package called ino in order to build the Arduino from command line. So it's fetching the libraries now, and now it's compiling the libraries. You can pay attention to here because once this is done, then it will program the Arduino. If we go back, we can see that this is currently being built. And then this is complete, then it will use the deploy to Arduino job. Okay, so this is built now, and it succeeded. With the green tick, we can say that it's passed. Like I mentioned, since we are using the free version of Github that is on cloud, this might take some time according to the availability of the running jobs on their system. Sometimes it takes a few seconds for this to start, but currently I think it's quite busy. So we are currently waiting for the deploy to Arduino to be initiated. Then we will see here. So now it's finished, and you can see now the LEDs are green and red as we have changed it in the source code. So we could extend this pipeline by adding some test jobs in between to do even maybe some kind of emulation of Arduino code before programming it to the device. But basically, this is the concept of using the CID tools and also the runners and physical devices connected to the DevOps.